subtracting rational numbers, and we're going to specifically look at fractions. So we have to remember our integer rules for subtracting integers, and also our rules for fractions. With the fraction, you have to get a common denominator first. So that's really what I want to do, is I want to look at these fractions and make sure they have the same denominator, because remember that denominator determines the size of the piece, and we're taking pieces away or putting pieces together, and they need to be the same size. Okay, so after I make sure I have a common denominator, then I'm going to use my integer rule for subtraction, which is keep, change, change, because I know subtraction just means to go the opposite direction of addition. So I'm going the opposite. So negative 2/3 plus negative 4/3. And since I have a common denominator, I'm good to go. I know my denominator remains whatever this is, because I'm adding up how many thirds I have. And when I'm adding integers, negative 2 plus negative 4, since I have the same sign, I'm adding them up and keeping the sign. So negative 2 plus negative 4 is negative 6/3. If you get this far, I'm going to be happy, but if you can reduce this, I'm going to be even more happy. So negative 6 divided by 3 is negative 2. So the final answer for this is negative 2. We continue with subtracting rational numbers, and now we're going to look at specifically mixed numbers. So we're going to use our rules for subtracting mixed numbers and our rules for subtracting integers. We're combining those things we already know. Now remember, with mixed numbers, when we add, subtract, multiply, or divide, we always want to change them to improper fractions. So let's do that first. So 3 times 1 is 3, plus 1 is 4/3, and it's negative, minus 2 times 1 is 2, nope, 2 times 2 is 4, plus 1 is 5 halves. Now I'm in the fraction mode, and I have to get a common denominator, because I know when I add or subtract fractions, I have to have a common denominator. This one's a 3 and this one's a 2. And they need to be the same size before I can add or subtract them. So I'm going to rewrite them with a denominator of 6. And I ask myself, what do I multiply 3 by so that I get 6? It's by 2. And so 4 times 2 is 8, and that makes negative 8. Then I ask myself, what do I multiply 2 by so that I get 6? It's by 3. And 5 times 3 is 15. So now that I have a common denominator, I'm going to keep, change, change. So I keep my negative 8, 6, change to addition, and change to negative 15, 6. All right, I'm ready to go. Remember, we add up our numerator, so I have negative 8 plus negative 15 over 6. We keep the denominator, because we're seeing how many 6s we have. So I have the same sign. Since I have the same sign, I add them up, and 8 and 15 give me 23, so it's negative 23, 6. If you get there, I'm going to be cheering for you. But if you can get past that, we're high-fiving, where it's good. We want to get past this. And I ask myself, how many groups of 6 are there in 23, or how many times does 6 go into 23? It doesn't go in there 4 times, because 6 times 4 is 24. So it goes in there 3 times. And I'm going to take that negative, put it on the whole number. And I know 6 times 3 is 18. So there's 5 left over out of 6. So negative 3 and 5/6 is my final answer.